All right, guys, this is the second part of this homework help video in which I do numbers 5 through 6, okay? So let's get on to number 5. A photon of electromagnetic radiation has a frequency of 6.56 times 10 to the 14th hertz, okay? Right here. Now, this means that 6.56 times 10 to the 14 waves of electromagnetic radiation hit you every second. That's 656 trillion waves. Yeah, trillion waves hitting you every second. That's a lot, all right? That's a lot of waves, okay? So what must the wavelength be in that case? Well, once again, we are going to go to the homework sheet. Okay, number 5. Now, this again is a wavelength frequency problem. They talk about wavelength, they talk about frequency. So I'm going to use this same equation. The speed of light equals the wavelength times the frequency. Okay, the speed of light does not change. It is the same. It is a constant. It is 3.00 times 10 raised to the 8th meters per second. That's about 300 million meters every second. That is fast. Light travels very fast. Now, I don't know what the wavelength is here. That is the unknown. That is what I have to be looking for. But I do know the frequency. They told me the frequency was 6.56. Make that a little neater here. 6.56 times 10 to the 14th. Well, this is the exact same thing as before, guys. We want to get the wavelength by itself, so we divide both sides by the frequency. 6.56 times 10 to the 14th. 6.56 times 10 to the 14th. Okay, so let me just put this into Google. Here we go. All right, the speed of light, so 3.00 times 10 to the 8th divided by 6.56 times 10 to the 14th. By the way, guys, as soon as you enter this in, you could probably just like control copy what you typed in here and paste it in as your work. All right, you can paste it in as your work. You don't have to be doing what I'm doing unless you keep getting them wrong, and you probably need to show a bit more work. All right, what's the answer here? 4.57 times 10 to the negative 7th. All right, 4.57 times 10 to the negative 7th. Does that work? Hey, it works, and this is meters. All right, so by the way, if I want to show my work here, I can just copy this. All right, control copy, and I can just, paste it in the work section right here. I could say C equals wavelength times frequency. All right, and then I can just paste in the work that I did. All right, bam, and then that'll be good if that's what you want to show me. Okay, but you do want to be working out the full work like I'm doing until you get a good handle on things. Okay, so let me do. Let me make sure I write this in here. Wavelength equals, and my memory is terrible. So what did I say? 4.57. 4.57 times 10 to the negative 7 meters. Okay, here we go. On to number 6. Okay, number 6. A photon of electromagnetic radiation has a frequency of 6.91 times 10 to the 14th hertz. 6.91 times 10 to the 14th hertz. What is the wavelength? This is the exact same kind of problem as the one directly above it. So once again, I'm going to write down the speed of light equals wavelength times the frequency. Okay? Speed of light does not change. It's always that. The wavelength, we do not know. All right, but the frequency, the number of waves hitting us every second, is 6.91 times 10 to the 14th, roughly 691 trillion waves every second. Okay? Now we're trying to find, let me use a different color for this one. Let's do Yada, 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 yada. Pink. Trying to find the wavelength here. Well, what do? We got to get this wavelength by itself. So let's divide both sides here by 6.91 times 10 to the 14th divided by 6.91 times 10 to the 14th. Once again, I'm going to put that into my calculator, which I'm just using this guy right here. So 3.00 times 10 to the 8th divided by 6.91 times 10 raised to the 14th. And what do I get? I get 4.34. 4.34. All right, 4.34 times 10 raised to the negative 7th meters. All right, great. 4.34. Let me write that in. Okay, now we got the last problem on the homework, number 7. And I saved the last one, a little bit trickier than the others. Let's take a look, okay? So this last question, a photon of light has a wavelength of 606 nanometers. What is the frequency in hertz, okay? So listen, folks, listen. For this, in order to use the wavelength frequency equation, you need to have the wavelength in meters. So our first step is going to be to convert 606 nanometers into meters. That's going to be the first part. All right, so part 1, all right, convert nanometers into meters. So 606 nanometers, and we're trying to convert it into meters. Okay? Dimensional analysis tells us we want to get rid of nanometers, got to be on the bottom. Meters on top. So 1 meter is 1 billion nanometers. So we're dividing by a billion. All right, we're going to take 606, divide it by a billion, and at this point, I can tell you that after plugging it into the calculator, that equals 6.06. All right, 6.06 times 10 to the negative 7th meters. You might have noticed, guys, that 10 to the negative 7th and 10 to the 14th pop up a lot. That's not a coincidence, okay? Since we're dealing exclusively with the visible light spectrum, all of the wavelengths are in the 10 to the negative 7th meter range, and all the frequencies are in the 10 to the 14th range. So you're going to be seeing that a lot. That's not universal for all electromagnetic radiation, just that electromagnetic radiation in the visible spectrum, the light that we can see, okay? So anyways, we got our wavelength in meters, all right? This is our wavelength. Okay. Now we're going to go to the speed of light equals the wavelength times the frequency. Okay, once again, speed of light, c, is a constant. It's always 3 times 10 to the 8th meters per second. That's equal to the frequency, which is, as we just calculated, 6.06 times 10 to the negative 7th. What is the frequency? What is the frequency? Well, this is the same thing we were doing before now. Okay, I'm just going to divide to get frequency by itself. 6.06 times 10 to the negative 7th. Okay, so 3 times 10 to the 8th divided by 6.06 times 10 to the negative 7th. Let's find out. Let's find out what this looks like. All right. So 3 times 10. I'm going to do this. Okay, 3.00 times 10 to the 8th divided by 6.06 times 10 to the negative 7th. And I get, what do I get? 4.95 times 10 to the 14th. 4.95 times 10 to the 14th. A hertz. All right. Fantastic. Now, guys, I've been just doing this in E here, okay? If you wanted to do the times 10 raised to the, it will accept that too. All right, I could do 4.95 little times symbol 10 raised to the 14th and still correct. Okay, so any of these formats would be correct. I think it'll also even accept if you made that like a little X instead. Would that work? It would even accept that. Okay, so all of those formats for your answer are acceptable. So there you go, guys. That's your homework. Please don't forget to attach your work to your homework sheet. Don't forget to attach your work to your homework sheet so I can check your progress and help you troubleshoot this stuff, okay? Because this stuff can be tricky, right? This stuff can be tricky, and I want to make sure you're doing okay. All right, 4.95 times 10 to the 14th hertz. Cool. All right. There you go, guys. That's it. Good luck with everything.